Imagine building an AI system, right? One that's meant to give you totally up-to-the-minute information, maybe pulling from the web.
Okay.
Now, how do you even start to trust that system? Especially when the world it's looking at, the information source, and even the kinds of questions people ask it. They're constantly shifting.
Yeah, that's a huge challenge.
It really is. It's a kind of a foundational challenge that's quietly, disrupting how we build and even verify AI.
Mm,
So today we're taking a deep dive into exactly that, this incredibly complex world of evaluating AI search. We're drawing some really powerful insights from a fascinating collaboration between Quotient AI and Tavily.
that's really the heart of the problem we're tackling.
Hmm.
Traditional monitoring methods, they just can't keep pace with modern AI.
Why is that exactly?
Because these AI agents are fundamentally different. They're dynamic. They made real-time decisions based on web content that's always evolving, user interactions, complex tool chains.
Right.
It isn't just like faster software. It's a fundamental shift in how we even think about AI reliability.
So it's not just one potential problem.
No, definitely not. It's
Yeah.
not just one thing that can go wrong. They have multiple, interconnected failure modes. Things like hallucination, where they just state something false with total confidence,
Okay.
or retrieval failures, they can't find the relevant info. Even reasoning errors, where they misunderstand what they do find. And the tricky part is, all of these can happen at the same time.
Wow. And given that level of unpredictability, how can you even start to measure their reliability without some kind of stable baseline?
Exactly.
And that sounds like precisely the problem Quotient AI set out to solve.
That's right.
They specialize in monitoring these live AI agents, detecting objective system failures, but without needing pre-existing ground truth data or human feedback or even those standard benchmarks.
Precisely. And we actually connected with Ram Tay, the CEO and founder of Tavily, and he laid out this crystal clear challenge.
Oh, yeah.
How do you build production-ready AI search agents? The kind that power real-time apps. When your system is dealing with two fundamental sources of unpredictability you just can't control beforehand.
Two sources. Okay. What are they?
So first, Tavily's agents, they gather context by searching the web. And the web, well, it's not static.
Right. Always changing.
Exactly. Traditional benchmarks, they assume this stable ground truth. But with real-time info, truth itself is kind of a moving target.
Okay, that's one. And the second?
The second is your users. They don't stick to nice, neat test cases. They ask these odd, malformed questions, sometimes with implicit context you're just totally unaware of.
Oh, yeah, real users.
And this isn't just theoretical, right? Tavily processes hundreds of millions of search requests in production.
Yeah.
So they need a solution that actually works at massive scale in these messy, real-world conditions.
Hundreds of millions. That scale is immense. It really puts the problem into perspective. And Tavily is doing some seriously impactful work with this.
Mm.
I mean, think about it. An AI legal assistant giving instant case insights for legal and business teams, helping them cut through just mountains of documents in minutes.
Huge time saver.
Or a major sports news outlet using a hybrid Arga chat agent. That's retrieval augmented generation, where the AI searches and integrates external info to deliver real-time scores, game stats, news updates.
Yeah, things people want now.
Exactly.
Yeah.
And maybe most critically, you mentioned a credit card company using real-time search to fight fraud by pinpointing merchant locations right when transactions happen. It makes the problem feel very, very tangible.
Absolutely. So, as you can imagine, evaluating a system in that kind of vast, fast-moving setting, it's quite challenging.
I bet.
We guided our evaluation approach with two core principles. First, since the web is the foundation of our data and it's constantly changing, our evaluation methods must keep up. You can't use static methods.
Makes sense.
Second, truth is often subjective. It's contextual. Evaluating correctness can be tricky because what's right might depend on the source or the timing or what the user actually needs.
So how do you account for that subjectivity?
Well, it means we have a responsibility, really, to design our evaluation methods to be as unbiased and fair as possible, even when, absolute truth is hard to pin down.
Okay, let's unpack this a bit. When we talk about AI evaluation, I think a lot of people, maybe you listening, immediately think about benchmarks like OpenAI's Simple QA.
Right, a common one.
And for good reason, they've been foundational for those short, factual questions with single empirical answers. Or maybe Hotpot QA, which tests the system's ability to answer more complex, multi-hop questions needing reasoning across different documents.
There's some multi-hop.
And it's worth noting, many leading AI search providers, they still use Simple QA to evaluate their performance.
And, while those static data sets are a great starting point, they really do have significant limitations when you're talking about real-time AI.
Like what?
Well, they just don't keep up with rapidly evolving information, especially if you're trying to measure if your system avoids regressions like getting worse over time on recent stuff. They also really struggle with subjective questions, where there isn't a single true answer, or where context is just everything.
So the benchmark itself is outdated almost immediately.
Pretty much. The core insight here is that for real-world AI, your evaluation framework itself needs to be as dynamic as the AI it's testing. Static benchmarks are, I don't know, like trying to judge a Formula One race car based on how it performs sitting in the garage.
Huh, good analogy.
Ultimately, you just can't answer today's questions with yesterday's data.
Okay, so if yesterday's data can't answer today's questions, then the critical question becomes, how do you build a benchmark that truly keeps pace with this ever-evolving digital world?
Right.
And this is where this ingenious approach of dynamic datasets comes in, offering a really compelling answer.
Exactly. They are essential for benchmarking RAGs in real-world production systems.
And what are the benefits?
Well, they offer real-world alignment. For starters, much broader coverage because you can easily create evaluation sets for basically any domain or use case that's relevant to your specific needs.
Ah, so tailored evaluation.
Precisely. And they ensure continuous relevancy because they're regularly refreshed. This means your system is always being evaluated against the latest, most relevant data.
And that continuous relevancy sounds crucial.
It absolutely is, which led us to build an open source agent specifically designed to build dynamic evaluation sets for these web-based RAD systems.
An agent to build the tests?
Oh, yeah.
Okay.
And this agent leverages the LangGraph framework, which essentially helps define and orchestrate the complex chains of operations these agents perform. Think of it like a workflow manager for their decision-making.
Got it.
It consists of a few key steps. First, it generates broad web search queries for targeted domains. This lets you create evil sets for any domain you care about, tailored to specific application needs.
So that first step is about generating that initial broad search. But then how crucial is it to avoid bias in the documents you gather, especially if you're evaluating your own system?
That's a fantastic question, and it leads directly into the second, really crucial step, aggregating grounding documents from multiple real-time AI search providers.
Ah, not just your own.
Exactly. We understood we couldn't just use Tavili's own search to find grounding documents and then evaluate our performance on them. That would introduce significant bias.
Makes sense.
Using multiple providers maximizes the coverage and truly minimizes that bias.
That's a smart move. Definitely ensures a fairer assessment. Okay, so once you have those documents from various sources, what's the next step? How do you turn them into something you can actually evaluate against?
The third step, and maybe the most vital, is generating evidence-based question and answer pairs.
Evidence-based.
Yeah. We ensure that in this generation process, the agent is essentially obliged to generate answer context. It has to show its work, so to speak.
I see.
This significantly increases the reliability of our Q&A pairs and helps reduce hallucinations, because you can always trace the answer back to the specific sources used to generate it.
And I imagine keeping track of all these complex, multi-step, offline evaluation runs. That must be a challenge in itself.
It can be.
Is that where something like Langsmith comes in?
Exactly. Langsmith is used as a great observability tool for this. It gives you a comprehensive view into every single step of your AI agent's execution, which is absolutely crucial when you're debugging and refining these complex systems.
Makes sense. So what's next for this dynamic evaluation agent?
Well, looking ahead, we definitely want to support a broader range of question types, including both simple fact-based questions and those more complex multi-hop ones, kind of like what Hotpot QA aims for. We also want to ensure fairness and coverage by proactively addressing bias, making sure we cover a wide range of perspectives for each subject we generate Q&A for.
That seems important for real-world use.
Very. And additionally, adding something like a supervisor node for coordination, especially when you have multi-agent architectures, we think that will increase the quality of our question and answer pairs even further.
Okay, so You might be listening and thinking, accuracy, right? That's the main thing to measure.
That's the common assumption.
But the philosophy here, it suggests we need to look beyond just getting the right answer. This concept of a holistic evaluation framework argues you also need to measure things like source diversity, source relevancy, and hallucination rates to truly understand an AI system's performance.
Yes, exactly. And to achieve that kind of evaluation at scale, and also to address that subjectivity issue we talked about, it's vital to leverage unsupervised evaluation methods.
Unsupervised,
Meaning they can assess AI performance without requiring a human to manually label massive amounts of data as correct or incorrect beforehand. This automation is really what makes evaluation at massive scale truly possible.
Gotcha. So to put these ideas to the test, an experiment was run, right? A two-part evaluation of 6 different AI search providers.
That's correct.
Part 1 compared accuracy on a static benchmark, that simple QA we mentioned, versus a dynamic benchmark, which was a 1,000-row data set created by Tavali's agent.
Right.
And Part 2 evaluated the responses from that dynamic data set using reference-free metrics, so without needing a predefined correct answer, and then compared those results back to the reference-based accuracies from the benchmark.
And the results were quite surprising, actually.
How so?
Well, on the dynamic benchmark, the correctness scores were substantially lower,
Yeah.
like across the board for all the providers.
Right, okay. A big drop.
Yeah. And even more strikingly, the relative rankings changed pretty considerably.
The order shifted.
Totally. For example, there was this provider F. It performed the worst on simple QA, but actually performed the best on the dynamic benchmark.
No kidding. That really highlights how misleading static evaluation can be for these real-world scenarios.
Absolutely. We also found that the simple QA LLM judge, the thing deciding correctness, while useful, it was far from perfect.
Oh.
It could incorrectly flag answers that were actually correct. Or, conversely, it might classify responses as correct, even if they contained hallucinations. It just fell short of truly identifying when things really went wrong.
This raises such a critical question for anyone building these systems. What if we don't have ground truths? Which, as you said, is often the case in production, especially with real-time AI search. So what do you do then?
Right. And this is where Quotient's reference-free metrics come in. They're designed specifically to identify issues without needing that ground truth.
Okay, tell us about this.
We look at 3 key ones in this study. First, answer completeness. This basically classifies responses as fully addressed, unaddressed, or unknown. That's if the model explicitly says, I don't know.
And how well did that track reality?
It showed a really strong correlation, 0.94, with overall performance, which indicates it can capture relative performance quite well on its own.
Impressive. Okay, what's the second?
Second, document relevance. Pretty straightforward.
Yeah.
It's the percentage of retrieved documents that are actually relevant to answering the question.
Makes sense. And the third?
Third, hallucination detection. This identifies whether any facts stated in the model's response are not actually present in the documents it retrieved.
Checking if it's making stuff up based on the evidence provided.
Exactly.
Now, this all sounds incredibly useful for real-time debugging. But here's a practical challenge the experiment uncovered, right?
Yeah, this is a significant one.
Of all the search providers tested, only 3 actually returned the retrieved documents they used to generate their answers.
Right, only 3 out of 6.
Most only provided citations, like links or document titles, which the study found are largely unhelpful at scale and also really limit transparency when it comes to debugging. That seems like a huge hurdle for effective evaluation and building trust.
It truly is. It makes applying these reference-free metrics much harder, or even impossible sometimes.
So what did you find when you could apply these metrics?
Well, looking at the insights from these reference-free metrics was fascinating. We found a strong inverse correlation between document relevance and the number of unknown answers.
Okay, explain that.
It matches intuition, basically.
Yeah.
If there are no relevant documents found, the model should ideally say, I don't know, low relevance, high unknowns.
Right, that makes sense.
But then, we saw a counterintuitive direct relationship between the hallucination rate and document relevance.
Wait, direct. So higher relevance meant more hallucination.
In some cases, yes. Provider X, for instance, had the highest hallucination rate, but also had the highest overall document relevance.
That is genuinely surprising. What's your immediate hypothesis there? Does it suggest some kind of trade-off we haven't fully grasped yet? Like maybe more detailed or interpretive answers inherently carry a higher risk?
Precisely. That's one strong possibility. This might imply that provider X is maybe more ambitious in its responses.
Yeah.
It's more likely to provide new reasoning or interpretations, or perhaps just be more detailed and comprehensive overall.
Okay.
And that just creates more opportunities for hallucination, even if the underlying documents are highly relevant.
Interesting.
So the key takeaway here is that different metrics, they measure different dimensions of response quality. And there's often a give and take, a trade-off involved.
It's not just one number tells all.
Not at all.
Ah.
However, when these metrics are used in conjunction together, they really help you understand why things went wrong and identify potential strategies for addressing those issues.
Can you give an example?
Sure. Like, if a response is marked as incomplete, but it has highly relevant documents and zero hallucinations, well, that probably means you simply need more relevant documents to fully answer the question. Your evaluation should do more than just rank providers. It should help you identify the types of issues and figure out strategies to actually solve them.
Okay, so wrapping this up, what does this all mean for you, the listener, as someone building or maybe relying on AI? Today, we've taken this deep dive into the absolute necessity of dynamic data sets for real-world AI, the power of a holistic evaluation that looks beyond just mere accuracy,
Crucial.
and the invaluable role of these reference-free metrics in truly understanding AI performance, especially when that ground truth is elusive or just non-existent. These aren't just, technical details. They feel like fundamental shifts in how we approach AI reliability itself.
Absolutely. And this isn't just about building better agents or better evaluation for today. This is really about painting a visionary picture of where we're heading with augmented AI.
Go on.
It's about creating AI systems that can continuously improve themselves. Imagine for a second, agents that don't just retrieve information, but actually learn from the patterns of what information tends to be outdated, or what sources seem unreliable, or what users really need based on follow-up questions.
Wow.
They could even potentially detect hallucinations mid-conversation and correct the course all without human intervention.
That's a powerful vision, and the frameworks we talked about today, these dynamic data sets, the holistic evaluation, those insightful reference-free metrics, they absolutely feel like the building blocks for getting there.
They are.
They're essentially teaching AI how to learn from its own mistakes in a world that's constantly changing around it.
Exactly. It's about building that self-awareness into the system.
So here's a final thought to leave you with, something to ponder. As these AI systems become inevitably more complex and more deeply integrated into our daily lives, how will our own understanding of concepts like truth and correctness need to evolve right alongside them?